Hello Internet! Today we're going to be taking a look at building our own operator overloads in C#. So operators are things that you use all the time. It's pretty much every one of the basic things that you do in C#. So if we have two strings, test and thing, we just use the plus operator. And so what C# exposes to you is the ability to implement your own version of these operators. And so there are some good and bad things that can come from doing that. There's a reason a lot of languages don't let you do this. But one of the advantages of exposing this is you can write your own things. One thing to be conscious of is that it should be obvious from the syntax what it's doing. It isn't always when you use some of these. And that can lead to some weird things because, like, for example, with numbers, you could override it so that plus doesn't actually add the numbers together. And then everybody gets really confused because your code doesn't make any sense anymore. So they can be handy ways to make more useful and easier to read code, but can also be dangerous and make your code really, really complicated if you're not careful. So we're going to make our code really complicated because I think that'll be fun. And it'll kind of show some of the things that are bad about this, but also I think it'll be just an interesting way to do this. So we're going to create a new class. This is going to be called our join string. That's a terrible name for it. But our join string is going to have a public string called content in it. And it's just going to be a property with a public getter. And so this is a read-only getter, which means it has to be set in the constructor. You can't set it at any other point because we don't have any value behind it. So whatever value we set that to in our constructor is what it's going to be for the life of that object. And so we can create a new public constructor for it of join string, and we're just going to give it the value of the content. And so we're just going to say this.content equals the content that we pass in. And now we have our thing. And so what I can do is do, let's see, var greeting, I guess. And we'll just say that's equal to a new join string of hello. And so, whoa, not like that. There we go. And so there's our hello. And we just need to add who we're greeting. So we're going to greet some name. And we're going to do WorldOfZero, something like that. And so this kind of gets us to this point. And so what I should be able to do is do greeting.content plus name.content. This isn't quite right, unfortunately, because we're missing the comma and the period. So I'm just going to do that there. Mostly this isn't a great example, but it's useful because it allows us to join these without having a third object, because that just makes the whole situation more complicated. It doesn't add anything, it just makes it more complicated. So we're going to avoid that. And so I should be able to run this now and get the same thing back. So if I do that, we should see hello WorldOfZero come back. We are missing our exclamation point because I didn't add it there. And we're missing a tab because for whatever reason, the previous one had a tab. I don't know where that was coming from, and it doesn't matter, so we're going to ignore that completely. But that was there. So we want to add an operator overload to do something really silly to this. The way this works is you make a public static thing. So a public static function that is going to accept or to return some value. And so in this case, we want to return a new join string so that you can chain multiple of these. And then it needs to implement the function of operator. We're just going to do the left-hand caret. And that is the syntax for this. And so this needs two arguments. It needs a left-hand side and a right-hand side, just like if you're adding these two things. Now, typically this would return some sort of Boolean, but we're not returning a Boolean. And because of overloading, you can have multiple of these do different things for different functions. So I could do something like this for join strings, and I could also do something like this for strings. There's a lot of reasons why that's a bad idea, and a few reasons why it's a good thing. Maybe those objects behave in slightly different ways. Maybe you have a stack and a queue and they have different functions, but you want them both to be supported. That might be an option. You could use an interface. That'd probably be the better solution, but if that isn't an option to you for whatever reason, you can overload it. The problem with this is the implementation can be entirely different. I can return different things. I could have this return, let's see, we're going to do a comparison of less than, and it's going to take a join string of x and a join string of y. The names here don't really matter, I don't think. We're just going to do that. And then we just need the opposite. This is a special function because it's greater than and less than typically, so you actually need to do this. Does it let me do this? Yeah, so this is fine now because all code paths return a value. If I had removed that function, this is going to have a different error for us. And it's going to say it requires a matching opposite side, just so that this can go both ways, because otherwise these functions don't make any sense. We're not going to be using them like that. What this is going to mean is this left arrow, that caret, is going to move a y and concatenate it to the front of x. So effectively we're going to do return new join string of y.content. So the right-hand argument plus the left-hand argument. So content, x.content there. And we're going to do the same thing for the other side. So we can join in the opposite direction. So x first and then y. Sort of like we're creating like weird pipes, but we're doing this with strings for some unknown weird reason. This is just a scenario that I dreamt up. I don't really know why you would do this. It just seemed like it would be more interesting than creating our own like adder or random list thing. And you know, I'm having fun with it. So this is going to just concatenate things and return that. We can do more with this though, because those are just pulling those out. Like I was saying, we can overload this. So we can just do strings, for example. And so I'm just going to plug in strings, and then all we have to do is drop the content off of those. And this all should be supported as well. I don't know how this is going to work. One of the parameters has to be the container type. Okay, that makes sense. So you would do join string of x and join string of x. This way, otherwise it wouldn't have any way of knowing if you were trying to concatenate two strings and get the join string result, or concatenate two strings and get the string-based result. So you need one of these to actually list it as the type, so it knows what you're talking about, because otherwise it's not going to have any clue. So we do this. Doesn't know what this is. I mean, what it's doing is calling the toString on this join string object. So I don't actually know what that's going to get us, but we can just return the content here. So x.content for both of those. And this just lets us join a string. And so what we can do is now write this in a whole bunch of different ways. So I'm going to leave that top one. That's just going to stay there. But we're also going to do this. Okay, this might get a little bit weird, but we're going to do that, which is taking the greeting, piping it into the name. The syntax makes no sense whatsoever. And then we're going to do this to do the opposite. So we should get WorldOfZeroHello, comma. I don't know if that's useful, but we're going to do that. And then we're going to do 2 for the string. So we have our greeting, and then we're going to do YouTube, I guess. So hello YouTube. And we can do the same thing again, just going in the opposite direction. I'm gonna make them match. So we'll be piping right and then pipe left in this. And so we should get different results. These two should be the same, and then this one should be reversed, and then we'll get the other ones. The only difference here is we are actually getting a cast, effectively, of figuring out, oh, this is a string. I know how to deal with that type, and so I can read that in and work with that. So this would be handy if, say, you need something that can accept any type of number, for example, and needed to do something specific with like floating points to bring them down into like real numbers or whatever. You could do that. Real numbers, whole numbers. You know, it's been a while since I've had to think about that, and now I'm confusing myself on which one is which. It's not really relevant. Why did we only get 2? I need to save that. There we go. All right, so we're going to save our class, and then we're going to run this. We should get 5 outputs. So the first 2 are the same. That's what we expect, because this is doing the same thing as this, just with our extra abstraction layer that makes everything more confusing. And then the next one is doing WorldOfZeroHello with no space because we didn't add the spaces at the end, and then the comma. And then we do the same thing with YouTube and get that. But this is just a really handy way to, I guess, overload functions. We're going to be probably using this in the future for more useful things. This is not useful, but it kind of helps illustrate some of the advantages of this, or at least some of the capabilities of this, so that you can kind of start thinking about maybe ways you might want to employ this. There's a whole bunch of operators that you can use, not just this one, but you could also, for example, use the plus operator, or the minus operator, or the multiplication operator, or the division operator, or the not operator. This one only accepts 1, I think. So this would do that. Yeah. So, okay, so that only accepts 1 operator and is like inverting it or doing whatever you want, but you can use a not operator, or an or operator, or an and operator, or like the caret symbol, or whatever. There's a whole list of these. I'll link to it. But you kind of get the idea of like there's different things, and sometimes this makes sense. So for example, with lists, you can add to lists using the plus operator. So to do that, we would do var list equals new list of string, something like this. We'll import it, and then we will do list plus equals test. Is that valid? Nope, but you can add lists to lists. Okay. I thought that was a thing, but it might not be. Anyway, that's pretty much all I had. You could probably make that a thing. That must be some other... Anyway, we'll ignore that. But the point is, you can override operators in C# to make it handle your custom types more nicely. This is probably more useful for like data types than it is for like controlling service-y types. But you can kind of figure it out. Like I mentioned at the very beginning, be careful, because what I've done here is kind of confusing. If I am reading this, it is not doing what I think it's going to do, because we're using this as a pipe and not as a comparison. If I try to compare things in an if statement, like if I try to do if greeting is greater than name, that isn't going to work. This isn't a valid if statement. But if I try to do test is greater than world, if I do that right, does this work? I don't know if you can do that. Nope. All right, that's not even a valid thing in C#. Well, there was an attempt. Anyway, point being, this doesn't make any sense. And that's probably not a good thing. Typically, the reason we name functions is because we want them to make sense. And so the reason these operator overloads exist is because there are operations that some types may actually want to do, that aren't implemented because you made a custom type for it. And so this gives you a way to add that functionality onto your type. Yeah, I think that's pretty much it. So I will leave it here. There'll be links to C#'s docs on doing this if you want to see what operators are supported, and some of the other like special cases. For example, the double and percent or double or for and or. Those are special cases. You can't explicitly override them, but overriding certain functions will cause those to change. Another thing that is useful to override is the equality one. You can change what it means for things to be equal. I think that might be different. I would have to check because I haven't really used that much. But that is it for this video. So I will leave it here. Hopefully this is something you can use, and if it's not something that you've used a lot, maybe you'll start thinking about how it's used and what are some of the advantages and disadvantages of using this. And if you do have good examples of use cases you've done, I'd really love to see them in the comments, just so that other people can kind of get an idea of patterns that make sense. So yeah, that's it for this video. So I guess until next video, see you internet.